Assalamu alaikum everyone. This is lecture 14 for CS116 object oriented programming. So let's get started. In the last lecture we discussed syntax for multiple inheritance and we saw what problem it imposes, like multiple inheriting from more than one classes. The problem occurs when we define a method having same name in more than one parent classes. Then MRO comes into play, which decides the search order in which a particular method or attribute is searched in the hierarchy. And we also saw that it becomes really, really complicated as you, uh, you know, increase the size of your hierarchy. So the examples that we did towards the end in the last session, they were really discouraging. Like, and I told you that as well, that programmers, they don't really favor this multiple inheritance, but there is a one very common use of this technique, multiple inheritance. We'll see that in today's lecture, which is mix-in classes. And then towards the end again we'll talk about that whether we should use multiple inheritance or not, or what alternates do we have to multiple inheritance. So let's see first what a mix-in class is. Mix-in class is a class which provides some functionality for other classes. Like you can implement a class that is not a proper class in itself, but it just provides a couple of methods or a single method that is a kind of general purpose method and that can be used by multiple classes. So you just provide that method in that class, and whichever class wants to make use of that method has to inherit from this particular class, right? This is the most useful form of multiple inheritance. Now you some of you might be thinking that this is similar to using modules or packages, or it is similar to importing modules or packages. So you are absolutely right. This is somewhat similar to that. You import a module because you want to access some function, some special function. So this is a second way of doing that. Like instead of importing a function, or instead of making a module or a package of your functions, you just create them as a class, right? And for modules, what you do, you just import them in your code, but here you can make them part of your hierarchy, right? So this, you can say, this is an alternate way for doing that. Okay, now let me show you the use of such mix-in classes through an example. So firstly, what I'm going to do, I'm going to implement a mix-in class. So this is the mix-in class which I'm going to implement. This class is called file saver, and the purpose of this class will be to provide a method which will save a list object to a file. So writing a list object to a file, we have been doing this in last semester, so the course should not be really alien to you. So let's write that code first. So here is my mix-in class file saver, and it does not contain any special attributes. It just contains a single method, and that method is called save to file. Now what arguments does it take? Self is that essential argument, and it takes one argument, file name. So the user of this class, or the user of this method, will simply pass a file name, and the object or the list on which this method has been called will be saved into that specific file. So what we'll do, we'll open a file with this file name, right? And since we are saving records, so there we have two options. We can either open it in append mode, or we can open it in W mode. So it depends how you want to use it. I'm opening it in W mode, which is write mode. Okay, now here we are writing a list, so there could be multiple ways for writing this list. What I'll do, I'll just traverse this list item by item, and then I'll save each item, or I'll write that each item in the file. So this for statement, it will traverse the list item by item, or index by index, and this is the simple statement that I can use to write that item in that particular file which I have opened. So f dot write. Okay, if you recall from last semester, we can only write strings into file. So this item, I'm converting it into a string, I don't know what kind of item it is. It could be a string item itself. Like I might be accessing some, I might be accessing this method on some list type. Oh, sorry, on some string, on a list of strings, or I could be accessing this method on a list of integers, or on a list of floats, or any other object type. So, or it could be a two-dimensional list as well. So to be on the safe side, I'm converting that item to string, or typecasting that item to string, and that backslash n at the end means that each item will be written on a separate line. So I hope this code is not really strange for you guys. We had done this previously, and then we'll close the file, and that's all. So this is my mixin class, and this mixin class, it provides only one method, and that method simply writes the list type object on which this method will be called, which I'll show you shortly how, into a file having that name, file name, right? Okay, now in order to show you its usage, what I'm doing here is, um, I want you to recall that phone book that we implemented in lecture 12. So I'll use this mixin class with my phone book class. So let's do that. Let's first recall that phone book class. This is the phone book class that we implemented there. Now, this phone book class, if you remember, I hope you remember, we inherited it from class list. I'm talking about that finalized implementation. Actually, this lecture 12 was about extending built-ins. So we implemented a class phone book, and this phone book was extending a built-in list. And we defined two explicit methods for this phone book, str and search. And list, since it's a built-in class, it has a lot of methods by itself, like append, sort, extend. Then there are many other methods which I have not listed here to save space. So this is the hierarchy that we implemented for this phone book class, right? Now I'll use this file saver class here, and I'll use this class to save my phone book to a file. Okay, now what I want to do here is, I have a hierarchy of two classes, list as parent class and phone book as child class, and I want to include this third class in my hierarchy, file saver class, right? So there are two ways for doing that. This is scheme one. In scheme one, what I am doing, I am inheriting phone book from both these classes. That means I'll add file saver class as the second parent of phone book. That is perfectly fine. This is an example of multiple inheritance now. So now phone book is will be able to use all the methods of list class, and it will also be able to save its list in a file by calling that method from file saver class, right? So this is first scheme, and there could be a second scheme here as well. And this is the second scheme, that what I do, I define a new class, and that class is called my contact, and I derive my contact from phone book and file saver. So my contact will be able to access the phone book and file saver directly, and it will also be able to access the methods of list class, because that's an indirect parent too. So this scenario is suitable if phone book has already been implemented, like somebody else wrote this and you are using that class, and you cannot change that class, or you don't want to change that class. You can create a third new class, in fact in this scenario, fourth new class, and then you can make it inherit from whichever class you want. So both scenarios are fine, but for now, or in this lecture, I'll implement scheme one. Now the code is really simple. Let's see it. This is a file saver class. I'm not writing the implementation again to save space here. This is my phone book class, and again I'm not writing implementation here, but we just saw that it contains two methods, str method and search method of its own. And then since it's inheriting from list class, it can use any or call any method of that class list. So let's instantiate an object of phone book type. Now this phone book type object book1, it can access all the methods of class phone book. It can also access all the methods of class list, and it can also access all the methods of class file saver. So first I'm adding a couple of entries. This is first entry. This will be saved in a two-dimensional list. I hope you are able to recall it, that we use that 2D list structure to store the information. So we'll append this first record, and then I'm appending a second record, and then I can simply call that method from file saver class, which was save to file, and I'm using this name. Now since you are accessing this on book 1, so the list that will be saved will be the one that is for book 1, right? I'll show you in animation shortly to explain this point. So for now you can assume, or you can just take it like as it is, that two-dimensional list that we have just created in phone book, that will be written to this file, my file. And after this code has been executed, what you can do, you can just go and check this file, myfile.txt, and you'll find this text over there, right? Okay, now in order to better explain the whole thing, let me show you what happens at the backend when this small code executes. So this was the first statement. As soon as you create this object called book1 of phone book type, some namespaces will be created at the backend. So let's see those namespaces one by one. First namespace will be of class list, right? Now this class list is contain a number of methods, and it contains some attributes also. But using that principle of data hiding in object oriented programming, this class list, it provides or it shows us the name of methods only. It never tells us what names does it use for the attributes or the variables at the backend. And we saw this while implementing that phone book class, that till end we didn't know, actually this list class was saving our list, but we didn't know the name of the variable of list type in which our list was saved, right? And we accessed it using that self argument, or that self keyword, right? So to make everything easy for me, I'm calling that unknown attribute anonymous list, ANON list. So this name written in blue is actually the variable name, which list class is not showing to us, so I've assumed a name for it, just to explain you the whole thing. And then append, sort, extend, and there is a whole list of methods that we know by name, because they are part of interface and they are accessible by name to us. So this is the namespace for class list. So it could contain many other class or instance variables also, but since we don't know them, so I'm just writing one variable which is of concern to us in this example. So anon list will be the list in which this list class will save our list, will save our phone book, right? And the remaining greens are the methods. This is the second class for which namespace will be created. And if you recall from lecture 6, what happens in a blueprint, in a class blueprint, it lists all the class variables as well as all the methods. So in this class file saver, we did not have any class variables. Class variables are those variables which are defined outside the methods, within a class but outside any method. So this class did not contain any class variables. It contained only one method, save to file, and it's there in this in this namespace. And this is the third namespace for phone book, and it also does not contain any class attributes. It only contains two methods, this str dunder method and search method. So these three namespaces or blueprints will be created, and along with this a separate namespace for book 1 will be created, because book 1 is an object, and we know that for each object a new namespace is created. And now since book 1 is inheriting from all these three classes in one way or the other, like list, file saver, and phone book, whatever instance variable exists in any of these class, they'll be part of book one, right? So we know that phone book class, it does not contain any instance variable. You can just go check the code. There was no variable which was accessed using self dot operator, so that means that class does not contain any instance variable. Same is the case with file saver, it also does not contain any instance variable. But anon list is an instance variable, and we access it using that self operator. In fact, since we don't know that name in our code, self is enough for accessing this. So this will be part of book one. That means that if I define another object of the same class phone book, let's suppose book 2, then this variable will be separately be defined for book 2, because this is an instance variable, right? So this is the scenario. As soon as you define this object book 1 of phone book type, a separate namespace for book 1 will be created, and separate namespaces for each class, which we used to call blueprints, class blueprints, they'll be created. So in this case, we have up till now 4 namespaces. And you see, book 1 does not list any of the codes or any of the methods. Methods are defined only in blueprints, because methods, they do not change when you execute the code. So you do not have to define separate copies of those methods in each object. But instance variables, they can be different for different objects. So each object maintains its own copy for instance variables. Okay, now let's see what happens when this second statement is executed. Here we are calling this method append. Now, according to our rule, that MRO rule, this method append will be searched in the current class first, that is phone book, right? Since it's not there, then the left parent will be searched, which is the list class, and this method resides there. Append is part of class list, so it will be executed from class list. So let's suppose it is executed from class list, right? And when it's executed, what it does, it actually writes this entry, or inserts this entry into our list, which we are calling anon list in this case. So now contain this one item, and just to save space, I'm using that dot 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 at the end. Actually, it contains this whole record. A non-list, if you recall, is a 2D list, right? So this is the first item in that 2D list, which itself is a list. Okay, and when this method is finished, that namespace for that method append is gone. I hope you remember that a separate namespace for each method is created. So a separate green namespace for that method append was created, and now it's gone because the method is done. But that entry still remains in that list, anon list. Okay, now same thing, or the same process will be repeated for the second entry. Again, this append method will be searched in the current class, which is phone book, and it's not found there. So class list will be accessed and it's there. So a new namespace will be created for this method append, and what it will do, it will add another entry to our anon list. So here it is, right? Once that method has been executed, that namespace is gone, but the entry in the list is there. Okay, then this fourth line will be executed, and this is calling a method save to file. So according to our search order, first it will be searched in the current class phone book, it's not there. It will be searched in the left parent, which is list class, it's not there. Finally, Python will come to the rightmost parent, which is file saver, and it will find it there. So save to file will be executed from the class file saver. So a new namespace will be called for this, and if you go see the code, you'll see that there were some local variables, f and item, that were used in this particular method save to file. So those local variables will be defined in this namespace. Append method might also have some local variables, but since we do not know the internal implementation of class list, I was not able to list them there. But these are the ones that we know, because file saver is our own class. So f and item, they are not instance variables, they are not class variables, because they are not accessed using class dot operator, they were neither accessed using self dot operator. So these are local variables, and they exist only as long as this green namespace for save to file exists. So this method will be executed, and as a result of this execution, what will happen? A file will be opened, and this whole two-dimensional list, it will be written, item by item into this file, right? And after that, this method or namespace for save to file will be gone, but the file remains. So I hope this example or this animation, it clears the confusions regarding the namespaces created in hierarchies. Um, and you can ask any question in the live session if there still are any confusions. Now, as a second example, let's define another mixin class called file reader, and this file reader class will perform exactly the reverse function to that of file saver class. So file saver was actually saving the records in a file, and this file reader will read records from that same file or from any file uh, for which we pass the name as an argument to this class. So this is file reader class, and there is only one method in it, read from file. We are passing the name of that file which we want to read, and let's open the file. Since we are reading the file, so let's open it in read mode only. Now what we have to do, if you can recall, in file saver function we wrote the list line by line, like each item of the list on a separate line. So we'll just use a reverse strategy here. So we'll just read the file line by line, and we'll keep on appending the items in the list. Okay, that self list. So here we go. This statement, it reads the file line by line. We know this for loop automatically works like that. So each time a line from this file f will be read into this variable line, which is a local variable, and we have to append it to the list. Here we are appending it to the list. And if you recall, we were storing it by converting it into string. So when you try to get it back into its original form, you will use this function eval, and we have been using this function in last semester as well. So I don't think I need to go into any further details for it. So these set of statements, they'll read the file line by line, and they'll keep on appending each item to self. And here self is pointing to that list that we have defined using that list class, right? Or whatever class which will use this read from file, or which will inherit from file reader, it can use this method on its own list. Then we can close the file after reading it. Okay, now let's fit this class in our hierarchy. I'm actually placing it in scheme 1. So now phone book can inherit from all these three classes: list, file saver, and file reader. I'm not writing code here because but the code is there in that file that I'm providing you with this lecture, and you can go through that code. There is nothing difficult in there, and that's why I think I don't need to discuss it here. Now one more thing that I want you to notice here is the name that I have chosen for these mixin classes: file saver and file reader. Now let's consider this file saver. I could have named this class something else as well. Like I could have named it save to file, and that would be absolutely fine. But one thing that you should take care, like for the sake of aesthetics, is that the name should fit in that is a relationship, because inheritance is a relationship. So if I say that phone book is a save to file, that doesn't make much sense. But if I say that phone book is a file saver, that looks better, right? So just remember to choose names that fit in that is a relationship for these mixers. So I can say that phone book is a list, phone book is a file saver, and phone book is a file reader. Okay, now I have a few tasks for you guys to do related to this, mix-in scheme 1 that we just implemented. The first one is this. This statement given in red, f dot write str self. This single statement can replace these two lines. These two lines of code, they are basically from from file saver class, and if you recall, we use these to write our list item by item in the file. So you can replace both these by the single statement. Now you can pause here and think about it, that what difference will it make. uh, like, I want you to think over it first, and for that you can pause right here, and you can come back and see what my answer is. Now when you will do this, you will see some surprising results. The main difference between these two is that this statement given in red, this will write that object as a whole. Like, this is a general line that can be used with any kind of object, like not only list, but if it's some, some object of some other class type, some other user defined class type, then also it will work. Whereas these two lines written in black that we are already using in this file saver class, they are specific for list type items only, right? So this red statement is a general statement, and now you know what's the difference between these two. But still, when you replace these two lines with this red line, you will see some surprising results. So I just want you to explore that by yourself. Okay, now the second thing that I want you to do is, okay, now see, I made you replace those two statements with that single statement in you can say question 1. Now there is a reverse statement for this too. Like, you see, this self dot append eval f dot read, this is the statement that can replace the two statements in file reader class. Like, this can replace these two lines, right? So I want you to do this again, and normally this statement, this reverse statement, should work while reading the file. But when you'll read it, you'll see something, like it won't work the way we are expecting it to work. And I just want you to observe the output and find out what the reason is behind that problem. The next thing that I want you to do is answer this question. Do you think that the hierarchies that I showed you, those two schemes, scheme 1 and scheme 2, where we added those mixin classes to our phone book class, are these hierarchies complete? You have to justify your answer for this. And lastly, I want you to write code for scheme 2 given on slide 7. Like, I implemented the code for scheme 1. You just have to make certain changes in hierarchy, and you have to add a new class called my contacts. And let's see if you can do this, right? Now, before moving on, let's discuss that whether we should go for multiple inheritance or not. So as I told you earlier as well, that this is not a very preferred concept among programmers. Like, in Java programming language, they do not provide support for multiple inheritance at all. Like, C++ supports multiple inheritance, Python supports multiple inheritance, but Java doesn't allow this. So there are actually unnecessary complications using this multiple inheritance, right? So let's talk about that. The main problem in multiple inheritance occurs when we have a method or an attribute having same name in various classes along the hierarchy. So uh, not in this lecture, in today's lecture, we saw a very, subtle and a very interesting, useful example of multiple inheritance. But in last lecture, I showed you some hierarchies where it was not that easy to determine that search order, and in some cases it wasn't even working, in the last case especially. So those were some simpler examples. You can always think of much more complex hierarchies using this multiple inheritance, and that can result in inconsistent search order. So due to these problems, programmers in many languages, they do not prefer multiple inheritance. So this is the statement from your textbook, that book 1 by Dusty Phillips, which I really liked. That as a rule of thumb, if you think you need multiple inheritance, you are probably wrong. But if you know you need it, you are probably right. Like, only use multiple inheritance when you are absolutely sure that there is no other choice, other than using this. Now, what can we do? Uh, there are, or what probable alternatives do we have to multiple inheritance? For that, let's go back to this example. In this example, phone book class inherited from these two class, file saver and file reader, and they were used as mix-in classes. So what we can do, that instead of inheriting from these two classes, we can make these two classes part of phone book. That means that we can uh, change the relationship from inheritance or from multiple inheritance to association. Like we can make file saver and file reader part of phone book. Now the last thing that I'll show you in this lecture is how we can replace multiple inheritance with association. Now for association, we do not require any specific or special syntax. So it's just change of code. So we'll change the code and we'll place one class into another as an object, and we'll see that we can remove this multiple inheritance from our code. So considering the same example, phone book example, right now phone book is inheriting from three classes: list, file reader, and file saver. So what I'll do here in this example is that I'll replace file reader and file saver with association, leaving list as it is, right? So this was our former scheme using multiple inheritance, and this is going to be our new scheme, right? So these lines without any arrowhead, that's showing that now file saver and file reader are associated with phone book. Phone book is not inheriting from them, but these two classes, they are simply associated with phone book. Now, since we are not inheriting from those classes, file reader and file saver, we have to make small changes in those two classes. So let's see those changes first, and then we'll come to our phone book class. Actually, formerly what we had been doing, we were inheriting from these classes. So that means the method of these classes, file saver and file reader, they were accessible to self. Like we did not have to explicitly pass our list to these to the function of these classes, right? So we were explicitly calling them on self, and self was actually representing our 2D list. But now this is not going to be the case. So what change we have to make? We have to make two changes in file saver class. This method, I'm adding an object obj. Now this object, it could be of any type, and this is the object that we are going to write in this file. Actually, it's not going to be of any type. The implementation I'll be using will be suitable for list type only. So this obj should be some list which we are passing here, and along with the file name, and this list will be written into that file. So this is the code. You see, I have just replaced that self with obj. So I hope you are able to make out the difference between this code and the former code, that there we did not need to pass this obj explicitly, because we were inheriting from this class, and self can call this method on it automatically. But now this is not going to be the case, which I'll show you on next slide, like why it will not work. So here we are adding this obj as argument. Let's close this file, and the same change we'll make in file reader too. See, here also I've added this object obj, and I'm appending the lines which I'm reading from the file to this object obj. Okay, and since it is of list type, okay, now this is an important point. Since obj is of list type, I don't have to return it to the main class. Now this point I am leaving for you guys to think, that why shouldn't I return this to the calling class obj? Because you see, not in file saver but in file reader, you are making changes to obj. You are reading items from file, and you are appending those items to obj, considering obj is a list. So but I'm not returning obj to the calling function. Why will this work? I want you to think about it, and then we can discuss this in the live session. Now let's come to the phone book code. Let's see what changes we make here, or how we incorporate those classes as association now. So this is the class. See, the first change that I have made is that I have removed those two classes from the inheritance list. Now this phone book class is inheriting from only one class, which is list, right? Okay, these functions, they remain unchanged, so I'm not writing those codes here to save space. Okay, now this is a new method I'm defining in this phone book, in my phone book. And what this method will do, it will not implement that method all over again, but instead of that, it will instantiate an instance of file saver type, right? And then we can call save to file method of file saver type. Like I can call save to file method of onFS. So this is the statement. Although the name of these two methods are same, save to file, but they actually are different because they'll be defined into different namespaces, right? So you see, now I'm instantiating that object in my phone book class. Like I am instantiating object of file saver type in my phone book class. That means I'm embedding an object of file saver type in my main class phone book. Similarly, I can define another method, read from file, right? And here I'll define another object of file reader type, right? So fr is a file reader type object, and then I can call the method read from file on fr. And you see here, this self that I am passing in this method read from file and save to file, in both the methods, the first argument that I'm passing is self, and this self will replace obj in those respective methods, right? So there we added that additional argument obj. So here I am passing self, so that means the list, that 2D list that I am defining in phone book, that will be passed to obj, right? Now I want you to answer one question. Here I have made file saver object and file reader object part of phone book class. So this is association. What kind of association do you think it is? Is it composition or is it aggregation? So I want you to think over it, and then in the next lecture we'll discuss more about this association, composition, and aggregation, and we'll see some more examples. Now we have seen two implementations here, like one using multiple inheritance and the other using association. Which you think looks cooler? Like the code we have written here uh, is through association, is using association, but this code is not as neat as it was when we were using multiple inheritance. So this is designer's choice then. Like if you think that you can handle multiple inheritance without causing any complexities and ambiguities, uh, go for it. But if you think that that can cause errors, or that can make your code difficult to handle, then you can replace that using association as well. Okay, let's recap what we have done today. We discussed mixin classes, and we saw that this is the best way multiple inheritance can be used. Uh, you actually define these classes because you mix these classes in some other classes, so that's why they are called mixin classes. And the second thing that we discuss is that multiple inheritance is usually discouraged by programmers, because sometimes it causes unexpected complications, and the most preferable way to replace this is to replace multiple inheritance is association. Now you see, the example we did today is not a very complicated one. So here association is working fine, and multiple inheritance was also working fine. So again, it's designer's choice that whether to choose multiple inheritance or association. That's all for today. Thank you.